Right, today's lesson is going to be about the uses of radiation. So we've looked at alpha, beta and gamma radiation, and now we're going to have a look at how we can use these different types of radiation. So first thing I want you to do as a bit of a starter is try and write a definition for these four words. If you want to pause the video and try and write yourself a definition, and then as soon as you're ready, start it again and I'll go through them. Right, so should have written your definitions now. So I'll go through the answers. So we've got an ion, which is an atom with an uneven number of protons and electrons. So something that has got a charge. It's got a positive or negative charge. Should have heard that in chemistry before. Another one you should have heard of in chemistry before is an isotope. Okay, this is an atom with the same number of protons but a different number of neutrons, giving it a different mass. Next one. Atomic number is the number of protons inside an element, and that tells you what element it is. And the last one is the mass number, which is the number of protons and neutrons added together. So moving on, we're next going to have a look at the different types of radiation and what they can go through, because this becomes relevant to how we can use them. So I want you to try and draw this diagram in your books, and I want you to label which one of these is an alpha particle, which one is a beta particle, and which one is a gamma wave. So can you draw this in your books, pause the video again, and label each one, which one you think it is. Right, so you should have done that now. So I'll go through what they are again. So we can kind of see this from the diagram, but we should know as well from what stops them that the one that is stopped by paper is alpha. The one that is stopped by aluminium but goes through paper is beta, and the one that is only stopped by thick lead is gamma. Okay, so 1 is alpha, 2 is beta, and 3 is gamma. And these are the symbols here. You do need to learn these symbols as well, by the way. Okay, so you just need to know what they look like. You don't necessarily have to be able to draw them, but it might just ask you. It might just mention it, and it might not write the full thing. It might just, as long as you know that this is alpha and this is beta, this is gamma. Okay, moving on to our next bit then, we're going to have a look at how we can use these different these different radioactive particles for different things. So our first example is a medical tracer. So what's basically happening here is a patient is injected with a radioactive isotope, and this passes through the body until it reaches the affected area, and then the radiation passes through the body where it can be detected. So what happens if you've got something like a tumour in your body, or say you've got a blockage in one of your bloodstreams, so one of your arteries around your heart's got a blockage, and we need to see where the blockage is, they will inject a very low dose of a radioactive material into your body, and it will go around your body, and then you'll be able to detect where it is found. So I want you to think about now, and have a go at writing this down. So pause the video and have a go at writing this down before I tell you the answer. Which type of radiation should we use for medical tracers? Okay, so pause the video, have a go at writing it down. Okay, so what we should use is, we should use gamma. Okay. Now, the reason for this is that it is, well, it's twofold the reason for this, it's two reasons. First reason being that it is able to pass through the body easily. Okay, because it's the most penetrating. So it is the most penetrating. Okay, it goes through the most stuff. Okay, and this means it can pass through the body easily. Okay, there's another reason though. Also, it is also the least ionizing. Okay, so it can, so it causes less damage as it goes through. Okay, all right. So, okay, so just to summarize on the medical traces then. So we inject somebody with some sort of element which gives off gamma rays. Okay, this travels through the body, gets to a blockage, for example, and the gamma rays are able to pass through the body because they're the most penetrating, and they reach a gamma camera which can see where they are being given out from. Okay, and you get like a scan of the body and it will show, right, this blockage was exactly here because this is where all the gamma's coming from. And it's really good to use gamma because it gets out of the body easily and it's the least ionizing, so it's going to cause the least amount of damage as it exits the body. Right, moving on to our next next use of radiation then. So we're going to have a look now at how we can use radiation to detect the thickness of something. So usually paper or foil. Okay, so a radioactive source is placed at one side of a material. So all the information is here that we need. This is what actually happens. So we have a radioactive source at one side of a material, and it gives radiation through the material to a Geiger-Müller tube, okay, which detects how much radiation's got through, and then can tell you if that's the right amount or the wrong amount, depending on what the thickness is. So let's say it produces 1,000 bits of radiation. Let's not worry about any units or anything. Let's make it simple. Okay. Now, if the paper's thickness is correct, let's say that 800 get through. Okay. Then that tells us the thickness is correct. But let's say there's something wrong with the rollers and 810 get through. Now that tells us the paper's now being made too thin because too much radiation's got through. If, on the other hand, there was 780 bits get through, that tells the paper's too thick and the rollers need to make it a bit thinner. So as long as it's at that right amount that's getting through, we know it's right. So let's think about which one we should use for this, which type of radiation. If we used alpha radiation, it's stopped, almost all of it is stopped by the paper, so that would be no good, okay, because too much of it would be stopped. If we use gamma radiation, almost none of it would be stopped by the paper or the foil or whatever it is, and therefore we can't use that because it's too penetrating, it goes through too much. So we use beta because that's just right, it's just the, it's like Goldilocks and the Three Bears, okay? Alpha was not penetrating enough, gamma was too penetrating, beta was just right. So we need to use beta radiation, okay? And the reason for that, like I just said, is, and you should be writing these things down, so the reason you should use that is that beta, because gamma is too penetrating, so would all go through, and alpha is too easily stopped. Okay, by the paper or foil. So it might be paper, it might be foil, it doesn't matter, because if it was aluminium foil, less of the beta would get through. There'd be, I don't know, maybe 200 would get through. Okay, but same process applies here. You'd get some through and some not, and you'd have the right amount. Okay, so to summarize again, detecting thickness, we use a radioactive source which shines through the Geiger-Müller tube, and we detect it on the other side. Right, moving on to our last one then. So smoke alarms. So I want you to have a think about which one we should use for smoke alarms. So if I go through what it does, and then you can have a go again, try and write your own answer, and then I'll go through the answer again. So smoke alarms contain radioactive isotopes. So the radiation ionizes the air between two charge plates. We've got a positive and a negative charge, and we ionize the air in the middle because normal air can't carry electrons, can't carry charge. You might have done this when you've done electrolysis in chemistry. Normal water cannot conduct electricity, but if you've got some ions in the water, it can conduct electricity. Same with air. If you don't have any ions in the air, can't conduct. If it does, can conduct. So the ions allow the current to flow. When smoke is introduced, the radiation is absorbed and the air is not ionized. And so basically, when there isn't a current, that tells the smoke detector, right, there's not a current, that must mean there's smoke blocking it. So there's something wrong, I need to sound the alarm and get everybody out of the house, sort of thing. So we want something that is really good at ionizing the air, okay? But also think about, you don't want it to be able to escape very easily, because you don't want it, because you're going to be sat in that room with that smoke alarm all the time. So pause the video now and decide which one do you think, which type of radiation do you think we should be using for this. Write your answer down and then I'll go through it. Okay, so you should have written your answer down, how to go. And I'm going to go through the answer now, so you can check if you got it right and correct it if you need to. So smoke alarms should use alpha. So like I said, it's the most ionizing. So it's the best at ionizing the air. So we want the air to be ionized because that's going to tell us that there is a current, that's going to allow the current to flow, so it's going to flow better with an alpha source. Also, it is the least penetrating, so it won't be able to escape from the smoke detector. So by having it as an alpha source, basically I'm sat in my lab now, and I'm sat, and there are 3 smoke detectors in this room. They are all contain some americium actually, which is a alpha source, and that is not going to hurt me at all because they're sat on the roof and they're inside a plastic casing, so there's no way of those alpha particles leaving that plastic casing, and even if they did, they're only going to go a few centimeters in the air, so they wouldn't reach down to me, and okay, they're not going to harm me. So by being the least penetrating, that's good in this case because they can't get through the plastic casing and they're not going to cause any damage to anyone. So, going to move on now. I'm going to give you some exam questions to do. Okay, so the idea is that I want you to have a go at these and sorry, there we go. So I want you to have a go at these in your books, and I want you to send me your answers as a picture, please. So what I want to see from you today, if you are at home, is a picture of your answers to these 3 questions, please. Oh, sorry, these 2 questions, but one of them split up into 3 parts. So I want you to, you've got the marks that they're worth on there, okay? And you should be able to use your information you've already got to try and work these out. All right, and I want you to just send me a picture of your answers. So take a photo of it on your phone, or if you do it on a computer, you can just send me the Word document that you do, whatever's easiest for you, and just send it me through Teams or through an email, however's easiest, I don't mind. And I will get back to you with some feedback on what you've done right and what you've done wrong. Okay, and obviously I can see you've done the lesson then as well. So can you do those? Send me a picture of them, and I'll get back to you with some feedback. Okay, so that's the end of the lesson as well. So if you pause it on this, do the questions, and then you can, then you're done. All right, thank you very much. See you soon.